Hi. So we will be learning a little bit more about reasoning. That is the topic which we will be discussing today is quantifiers. So just a few basic terminology to get you acquainted with it. Consider the statement x equal to root 2. This is an open statement and x is called a free variable because x can take any value. Now, if x is replaced by any element of R, where R is the set of real numbers, then we say that R is a universe for x. So x can be any real number. So R is a universe. If I say x can be any element of n, natural numbers, then n is the universe for x. And open statements are denoted by px, qx, etc. because it can be any variable, any value of x. If u is the universe and a belongs to u, we call this statement PA. So PB means B belongs to u. Now let the universe consist of the set of all integers. Consider the following open statement: Px x less than or equal to 3, Qx x plus 1 is odd, and Rx is x is greater than 0. Write the truth value of P2. So P2, 2 is less than or equal to 3, so it is true. What about negation P3 disjunction R0? Negation P3 will be x is greater than 3. And P3, 3 is not greater than 3, so negation P3 is false. What about R0? Is 0 greater than 0? No. So negation P3 and R0 are both false, and false or false is false. So the truth value is false. So you can say negation P3 disjunction R0 is false. Now the third question, P4 disjunction Q1 conjunction R2. P4 is false. Why? Because P is x less than or equal to 3. 4 is not less than or equal to 3. What about Q1? 1 plus 1 is not odd, so again Q1 is false. And what about R2? 2 is greater than 0, so R2 is true. Now Q1 disjunction R2 will be false. Q1 conjunction R2 will be false conjunction true, which is false. And P4 disjunction that will be false disjunction false, which is again false. Now just some notations. For all is the universal quantifier. Their excess is called the existential quantifier. A proposition involving a universal or existential quantifier is called a quantified statement. So you have universal quantifier or existential quantifier. Now let the universe be the set of integers, and Px be x greater than 0, Qx be x is even, Rx be x is a perfect square, Sx be x is divisible by 3, and small, you can call this as, you can call it as say R1x. R1x be x is divisible by 7. So write the following quantified statements in symbolic form. At least one integer is even. So at least, that means it is, you can find at least one integer. So it's an essential quantifier. So their x is x, even is qx. So their x is x, qx. Some even integers are divisible by 3. Some means their x's. Even is qx, divisible by 3 is sx. So it will be qx disjunction sx. That means you can find at least one integer which is divisible by 3. If x is odd or not divisible by 7, then x is divisible by 3. So every odd integer which is odd or not divisible by 7 is divisible by 3. So it is for all. Universal quantifier. For all x is odd. Odd will be, so I'm just going to go up. Odd will be negation qx. Or not divisible by 7. So not divisible by 7 means negation R1x. Then x is divisible by 3. Divisible by 3 is Sx. So for all x, negation qx, conjunction negation R1x. That is, x is not odd and not divisible by 7. Then x is divisible by 3. So for all x, negation qx, conjunction negation Rx will be Sx. It's a little confusing here because though it is or, it means that x is odd and not divisible by 7. Only then it is divisible by 3. That's why we use conjunction here. Now, for all x belongs to x, px is true only when px is true for all x belonging to s. And there exists x belonging to x, px is false only if px is false for all x belonging to s. So understand this. When everything is true, you can say for all x belonging to s, px is true. And when everything is false, you can say there exists x belonging to x such that px is false. If px is true for all x belongs to s and a belonging to s, then pa is true. This is the rule of universal specification. And if px is true for any x belonging to s, then px is true for all x belonging to s. This is the rule of universal generalization. It's a little confusing, but as you do problems you will understand. But there are three rules. That is, for all x px conjunction qx if and only if for all x px conjunction for all x qx. Again, there exists x px disjunction qx if and only if there exists x px disjunction there exists x qx. And there exists x px implies qx if and only if there exists x negation px disjunction qx. So I've just given you the basic outline of quantifiers. Thank you. To practice, take a pen and paper, write down all this, and until next time.